Welcome class. This is our lecture on Laplace transform. In the previous sessions, we studied about Laplace and inverse Laplace transform and their properties. Also, we studied about Laplace transform of elementary functions. Today, we are going to take a very important issue where questions are asked every year invariably. That is application of initial value problem for second order linear equation with constant coefficients. So, we have done this and this. Now today, this is a very important lecture. So, what is a general understanding for this one? We will be seeing Laplace transform of y to the power n means n times it is differentiated. Then the value is s to the power n Laplace transform of y of t minus s n minus 1 y 0, okay, minus s n minus 2 y dash 0 2 y n minus 1 0. This is our claim for the nth term, but in our syllabus it is restricted to second order linear equation with constant coefficient. So we have to be very cognizant of the fact that what is the ambit of UPSC Civil Services Mathematics as regards to this topic. So we'll first start with y dash t or y prime. If we write it like this is the Laplace transform, if we write with t is equal to 0 to infinity e to the power minus s of t y double dash t y dash t dt, then we can solve this integral, and we will be solving this integral by integration of part. This is our first function, this is our second function. So we will take the integral of second function, keeping the first function constant, minus integration of second function into differentiation of first function and the whole function integration. So it will amount to e to the power minus st, y dash t integral is yt itself, limit runs to 0 to infinity, minus integral of 0 to infinity e to the power minus st. We will take its derivative. So its derivative with regard to t is minus s and its integral is y d dt. Okay, so if we put this value here infinity, what is e to the power minus infinity? It is 0, so we can write it 0, then minus what is e to the power minus 0? 1, and what is y 0? Here y 0, we can write it like this. So minus into minus, alright, will be plus, so we can take it outside, and this integral is 0 to infinity e to the power minus st y of t dt. So we can write it like this: this is the Laplace transform of yt, y of t minus y0. So this is what we will be doing. So for y prime 1, this is the formula. We will be using it when we will be taking the questions. Now, what is going to happen for Laplace transform of y double dash t? That is equal to Laplace transform of y dash t, and it can be taken away. So from here we can put this value. So its value is s Laplace transform of y of t minus y0, and this is prime or derivative. So when we write it, it becomes what? S Laplace transform of y dash t minus what is the derivative of y0? That is y dash 0. Now again, here in place of Laplace of y dash t, we are going to use this formula, what we have done over here. So we can plug this here, this equation's value. This becomes s Laplace transform of y of t minus y0 bracket close minus y dash 0. So if we will solve it further, Let me erase the upper portion. And this was our y of dash t. So this becomes Laplace of y double dash t becomes s square Laplace transform of y of t minus s y 0 minus y dash 0. So these are the fundamental equations that we will be invariably using in fact each of the question. So we have derived this for 1 prime and 2 prime. So this is the theoretical part of this topic, and now we are going to take some of the questions, and I will start with the recent question that was asked in civil services examination. Before we move further, please make a note of this because we are going to use it all the time. So the question, initial value question that has been asked, erase all of this, is y double dash minus 5y dash plus 4y is equal to e to the power 2t. Y of 0 is equal to 19 by 12 and y dash 0 is 8 by 3. So this was asked in IS 2018 for 13 marks. Now here I must tell you that what is the most important thing with regard to this. Now in examination, this is in our syllabus, we have to do it by initial value problem. It is imperative that you solve by Laplace transform and not by differential equation because it is explicitly mentioned in the syllabus. Okay, so I will proceed. Just now I have taken the Laplace transform of as s minus y0 and y double dash prime is s square Laplace transform of yt minus s y0 minus y dash prime 0. So we will put these values in the original equation. What it will be, s square, and what is the Laplace transform of yt, that is y of s minus s, here Laplace transform of y t can be written as, here yes it is s y 0. So what is it, s y 0 minus y dash 0. Okay, and what is the value over here, minus 5y. So this can be written as Laplace transform of y of s minus y of 0 plus 4 of y of s is equal to Laplace transform of e to the power 2t. So what it becomes, 1 by s minus 2. So now our job is to collect the coefficients of capital Ys here, here and here. So it will be s square minus 5s plus 4y s. What is the value of y0? Value of y0 is 19 by 12. So we can write it 19 by 12 here as. What is the value of y dash 0? 8 by 3. So we can write it as minus 8 by 3. Now we have already factored this into, all that is left is minus 5 into this minus y0. So it becomes 5 times of this value. So it becomes minus minus become plus. So it becomes 19 into 5 is 95 divided by 12 is equal to 1 by s minus 2. Alright. Now what we will do, we will take all of this on the right hand side. So the value is s minus 2 plus 19 by 12s plus, if we find this value, it is minus 63 by 12. So this is s square minus 5x 5s plus 4 y of s. So we will take the LCM, that is 12 s minus 2. This is 12 plus 19s into s minus 2 minus 63 s minus 2. Alright, so we can further simplify this and write here as 12 plus 19 s square minus 38s minus 63 of s plus 126 divided by 12 x square s minus 2. So we can get the answer here as y of s. This is, we will start with s square coefficient, that is 19 s square minus 38 and minus 63 is our 101s, and 126 plus 12 is 138 divided by 12 s minus 2. Now I will factorize this. This is s minus 1 into s minus 4, and I will take into the denominator. So s minus 1, s minus 4. So this we have got as y capital S, and we have to invoke inverse Laplace transform to get our y of t. Alright, now we will try to find that. So y of s can be factorized as a s minus 1 plus b s minus 2 plus c s minus 4. Okay, so we will take out the values of a, b and c and put it and take the inverse Laplace transform. So a is our limit s into 1 s minus 1 y of s. Alright, this is how we write this. We can further write as limit s tends to 1 and s minus 1 into, what is our ys? 19s square minus 101s plus 138 divided by, in denominator we have 12, s minus 2, s minus 1 and s minus 4. So this one get cancelled. We will plug the values here. Okay. So when we plug the value here, what do we get? 19 into 1, 19 minus 101 plus 138 divided by 12. 1 minus 2 is minus 1. Alright. And 1 minus 4 is minus 3. So further when we simplify, 138 plus 19 becomes 157, and 157 minus 101 becomes 56. So what we get, our answer is 56 divided by 4 into 9. Okay, we are decomposing it. So if we further to calculation, what we get? 14 by 9. So we get a as 14 by 9. Similarly, we will find the value for b. This is limit s tends to 2, and we can write it directly 138 12, and we have cancelled here s minus 2. So if we are going to put the value, what we will get here again? 19 into 4 is 76. 76 minus 101 to 1 into 2 is 202 plus 138 divided by 12. 2 minus 1 is 1. 2 minus 4 is minus of 2. So if we will add 138 with 72, what we get? We get 214, and 214 minus 202 is 12. So what we get? 12 by 12 into minus 2. So we get our b as minus half. And finally we have to find the value of c. The value of c is limit s tends to 4, 19 s square minus 101 s plus 138 divided by 12 into s minus 1 into s minus 2. Okay, so now we will plug the value of s. So this is 16. 4 into 4 is 16. 19 into 16 is how much? 304. And 104 into 4 is 404. So this is 19 into is 304 minus 404 plus 138 divided by how much? 12. This is 4 minus 1, how much? 3. And 4 minus 2 is 2. So 304 minus 404 is minus 100. So minus 100 and plus 38 is 38. So we can write it as 38 into 36 into 2. This can be cancelled. So we get 19 by 36. So we have got our values 19 by 36. Okay. So we will just invoke inverse Laplace transform and write the answer. So our answer is y of t is equal to 14 by 9. We will take the inverse Laplace minus 1, that will be e to the power t. Then this is half. This is 2t plus 19 by 36. Okay, 4 e to the power 4t. This is the answer. Now this is a very simple concept, but we can also do it in alternative method. So we can do also by alternative method, that is by differential equation, to verify the answer. So we have not done this differential equation part right now, but we can do it by differential equation, put the initial value and verify our answer. Why I am saying so? Because this is a trick to get your answer right, because if you do calculation mistake, that will cost you heavily. Now let me take another question that was asked in Civil Services 2017, and it is on the similar lines. The question says we have to solve by initial value problem 20 y double dash plus 4 y dash plus y is equal to 0, and our initial conditions are y0 32 and y dash as 0. So I can say this was asked in 2017 for 7 marks. Okay. So let's get started with the problem. Invoke Laplace transform for this one. That will be s square y of s minus s y0 minus y dash 0 plus 4 times s of y of s minus y0 plus y of s, and Laplace transform 0 is 0 itself. Bring the coefficient of capital Ys. So that is 20 s square plus 4s plus 1 y of s. So our y0 is 3.2 here, 3.2, as we can see from the question. Our y0 is 3.2. So we can write it as 20 minus s 3.2, that is minus 64s, and y dash is 0. So that is not factored into, but here y0 we have to take. So 4 into y0 is 4 times 3.2, that is your minus of 12.8 is equal to 0. So we can take this on the RHS. So what we are getting, 20 square plus 4s plus 1 square, this is equal to 64s plus 12.8. Okay, now we can write y of s as 64s plus 12.8, and we can factorize it taking s as common. So we get s square plus s by 5 plus 1 by 20. So if we write into the complete square, what we get? We get our answer as 64s plus 12.8 divided by s, and this can be compared s plus 1 by 10 whole square plus 1 by 5 whole square. Okay. Now we have to do partition. Here we have s plus 10 and here only s. So we will add plus 1 by 10 and subtract. So when we write that, and here what is missing over here is 20. So what we get is 20. We'll add s 1 by 10 minus 1 by 10 and have subtracted it, plus 12.8 divided by 20 s plus 1 by 10 whole square plus 1 by 5 whole square. So this is the format of writing, and we can write it as s plus 1 by 10 whole square plus 1 by 5 whole square. So we can bring it into the order. The 64 by 20 is how much? 3.2. So we can write it as s plus 1 by 10 whole square plus 1 by 5 whole square. Now 64 into 1 by 10 is 6.4, and 6.4 plus 12.8 is again 6.4, and so we can write it as 6.4 divided by 20. But mind you, we must have 1 by 5 here. So what we will do, we will write 1 by 5 here, s plus 1 by 5 whole square plus 1 by 5 whole square, and since we have taken 1 by 5, so we must take its reciprocal, that is 5 outside. So we will get this as, this is 4, so 6.4 is how much? 1.6 if we divide by 14. So we are in a very much position to take it inverse Laplace transform. Now I will invoke it and write the final answer. The answer is, first we will take the shifting, the 3.2 e to the power minus t by 10 Laplace inverse of s by s square plus 1 by 5 square plus 1.6 e to the power minus t by 10 Laplace inverse of 1 by 5 by s square plus 1 by 5 whole square. So our answer is 3.2 e to the power minus t by 10, and this is cos of 1 by 5t plus 1.6 e to the power minus t by 10, and this is again sine 1 by 5t. So this is your answer. Now I'll like to give you further some questions for assignment. So I'll give you some assignment so that in the next lecture you can come up with the answer. And these questions are y double dash minus 2y dash minus 8y is equal to 0, and initial condition is y 0 is 3 and y dash of 0 is 6. Second question is y double dash plus y is equal to t, y 0 is 1 and y dash of 0 is minus 2. These are the questions asked in IAS 2016 and 15 respectively. So you can solve these questions and write the answers in the comment section, and if you have any problem I will be taking up these questions. Thank you for watching. Please like, share and subscribe.